Hello, class. These are the notes for Tuesday, September 8th for chemistry class. Today, we're going to talk about how to measure things, how to measure the volumes of liquids, and how to measure the mass of some substances. So I want to start off by first talking about how are we going to read the volume of a liquid. Now, oftentimes we're going to do this by using a graduated cylinder. If you remember back from when we talked about equipment, there were two tools that we'd use to measure the volume of a liquid. One was a graduated cylinder, the other is a burette. The difference being a burette is for precise measurements, and it won't be that often that we'll need to be that precise. So the vast majority of the time, we're going to use a graduated cylinder, and I want to teach you how to read one. The first thing, though, I want to do is take a step back and talk about beakers, right? Because this is another piece of glassware that we'll use a lot. And we talked about this in equipment, so this is a quick refresher. A beaker, what's good about a beaker? They're very, very good at holding liquids, right? That's what they're designed to do. They're designed to hold liquids. They are not designed to measure the volume of those liquids. Even though there are the little marks on the side of the beaker, those are just to give you an idea of how much is in there. They are not used to measure, so we will use graduated cylinders. Two other things about our beaker. The first being that we read the number above the shape on the size, on the shape, right? So there's a little shape on our beaker. It'll be a triangle, a square, a hexagon, octagon, some sort of little shape that's shaded in. Look above that shape, and it'll tell you the size of that beaker. For example, 400 milliliters. One thing I want to make sure we all keep in mind, again, for safety reasons, is we're never going to fill a beaker more than halfway full in this class. If we need 300 milliliters of something, we're not going to use a 400 milliliter beaker, right? And again, it's just safety. If something's filled more than halfway, it's too easy to spill. So again, we'll just get a bigger beaker if you need more volume of the liquid. All right, so on to the graduated cylinder. So I've got two in front of me here. They're both glass. I'm hoping these show up okay. This one, because it's got this little red strip, sometimes it makes it a little bit easier to see and read. So I'm going to use this one for my example. I also have another one here, a smaller one. This one is, let's see if I hold a paper up behind it. It's got some tick marks on it too. All right, so what's good about a graduated cylinder? The graduated cylinder, it measures the volume of a liquid, right? And what we do, if you want to look at the volume, the units on this thing is milliliters. It's very important that we always know the units we're working with. I don't ever want to see you just write down a number. I always want to see the units that you're using for that. So our graduated cylinders, both of these, will measure the liquid's volume in milliliters, okay? Always rinse your graduated cylinder between uses. This is very important. If you put a chemical in it, measure it out, put it into your beaker or whatever else we're using for a reaction, and you come and put a second chemical in here, guess what? You just contaminated what you're putting into your graduated cylinder that second time. We don't want them to mix together. Sometimes it just it mixes them together, and it just makes it dirty. Other times it might start the reaction in your graduated cylinder. Not a good thing. All right, so always rinse your graduated cylinder between uses. Now, if you noticed, I showed you two graduated cylinders. We're going to use both sides this year in chemistry, and that goes around to the point 3 on this slide. I want you to use the correct size for what you're measuring. Right? So, for example, say I asked you to get 7 milliliters of a chemical. Right? Would you use a 10 milliliter graduated cylinder, a 50 milliliter graduated cylinder, 100 milliliter graduated cylinder, or 1,000 milliliter graduated cylinder? Well, hopefully you guys said 10 milliliters, right? Let's use the one that's closest to our number that we're looking for, right? 7 milliliters. Now, if we needed 13 milliliters, yeah, that's bigger than this 10 milliliter graduated cylinder can handle. So we just measure 10 the first time and 3 the second time. Much more accurate, much more precise, rather, if you use this guy to measure 13 milliliters than this guy. Both can do it, but let's use the instrument that's better used, more precision for what we're doing. Now, if we're talking 40 milliliters, you don't want to be filling this thing up 4 times. At this point, right, then you would use the bigger one. But use a little bit of common sense, okay? So the next thing I want you to be aware of is the increments, point number 4. If you look at the 4 diagrams I have here, this first one, 0, is and then we have a big tick mark here, and then we have another really big tick mark at 10. Right? So what this is telling us is this is 10 milliliters, And we got to look at this. Now, hopefully it makes sense to you guys if you're reading rulers and stuff. If there's another tick mark that's a little bit bigger, half in between, this one's probably 5. This one's going to be 5. So let's count the number of tick marks between that 0 and the 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 tick marks between the 0 and the 10. So how much is each tick mark? Well, we went 10 milliliters. It took us 10 tick marks. We're going to divide those numbers by each other. 10 milliliters divided by 10 tick marks. 10 tick marks divided by 10 milliliters. That tells you that each tick mark is 1 milliliter. All right. Each tick mark is 1 milliliter. So I want you to be aware of the increments on the tool that you're using. This goes whether you're talking about a ruler, graduated cylinder, anything. If there are little tick marks on there, make sure you know what they are, right? What size they are. You're going to have to read it. And I don't want you ever writing just down a number. You're going to put the units. So we just talked about this first graduated cylinder. Its increments are in one what? 1 milliliter. 1 milliliter. Okay. So let's look at our next graduated cylinder here. We have 0 and a 10. All right, how many tick marks are between them? 1, 2, 3, 4, 5. So we got 10 milliliters. We got 5 tick marks. So we're going to take that 10 milliliters, divide it by the 5 tick marks, and what are you going to get? 2 milliliters per tick mark. All right. So the second graduated cylinder, not quite as precise as the first one, right? Because it can only measure to the 2 milliliters, whereas the first one can measure down to 1 milliliter. Let's look at our third one. Our third one, we have a 0 and we have a 1. So not a 10 like we did in our first few. This one's a 1. How many tick marks? 1, 2, 3, 4, 5. So we have 1 milliliter per 5 tick marks. 1 divided by 5, that is 0.2. And again, our units are milliliters. So this guy here, this would be our most precise graduated cylinder if we want to measure volume. And finally, our fourth one, what do we have? We have a 0, we have a 1. There's 2 tick marks between them. So we're going to divide that 1 milliliter by 2 tick marks, and we're going to get 0.5 milliliters per tick mark. It's very important that you understand what the increments are on the tool that you're using. All right. Another thing about reading a graduated cylinder, you need to read the graduated cylinder at eye level. Now, if that means I would advise not necessarily picking it up to read it because you're not sure you're holding this level. Put your graduated cylinder on the desktop. Move your eyes down so you can see. You're looking eye level right at that liquid in your graduated cylinder. Now, if you look at in my drawing here, there's this little curved surface. That's what we call a meniscus. Right? Water has something called surface tension, and it tries to climb up the sides of of whatever container it's in. And the smaller the container, the more obvious this is. Right? The more you'll see that curvature. So when you're looking at it, I want you to look at that meniscus. When we read it, we're going to look at the bottom of that meniscus. So this one right here, this is 50 milliliters, not 51, right, as it curves up to the side. Read your meniscus at the middle. Okay, so important term here. I'm going to make sure you remember this meniscus. You might see that on a quiz or a test. All right, one more piece again on how are we going to read that graduated cylinder. Now, in this particular drawing, I drew it so that the curvature, the bottom of that meniscus, is right on that 50 milliliter line. That is not going to happen very often. More often than not, it's going to be like you see in these two pictures here, where the meniscus, the bottom of the meniscus, is between 2 of our tick marks, 2 of our increments here. Right? So this is what I mean. It's not always right on. You need to read one place after that last line that you see. In other words, we're going to estimate that last line. So let's look at this first graduated cylinder. 60 up to 65. How many tick marks in between them? 1, 2, 3, 4, 5. So we know each tick mark is 1 milliliter. Each tick mark is 1 milliliter. 5 milliliters divided by 5 tick marks, 1 milliliter per tick mark. So let's look at where is this line, right? So we're at 61, 62, 63. So we can read right off of our tool here, it's 63. But it's not right on that line of 63. It's a little bit above it. So we look at that line and say, okay, is it more than halfway between the 63 and the 64? And we're going to look at this one and we're going to say, yeah, it's more than halfway. So we know it's at least 63.5. So now I'm going to say, let's draw another little imaginary line there halfway through. And we're going to say, how close is the bottom of our meniscus to that 63.5 line, that imaginary halfway line, and the next tick mark. I'm going to say it's a little bit closer to that top tick mark than it is our halfway line. So instead of being 63.5, we're between 63.5 and 64, a little bit more than halfway. So I'm going to call this one 63 point, let's say 8. Right? 63.8. So remember, we're going to read that 1 point of estimation. Very, very important. Now, we might not agree on that last number, right? So I said 63.8. You might say 63.7. You might say 63.9. That's fine. We both better say 63 because we can read that right off the tool. It's that estimated number is a little bit different. That's okay. We should be close. Now, hopefully we're not going to say 63.1, but we should be close. 63.7, 63.8, 63.9, somewhere in there is good, right? So don't worry too much about it. Just do the best estimate you can. All right. So we look at the next one here. Again, what are we at here? Whoop. We're at 79. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tick marks. We went up 1 milliliter and it took us 10 tick marks. So each tick mark goes up 1/10 of a milliliter, 0.1 milliliters. So here we are. We're at 79, 79.1. So we at least should read 79.1 together the same. Right now we have to estimate that next digit, that last digit. I'm going to look at that one, and I'm going to say that looks pretty doggone close to halfway between the 79.1 and the 79.2. So I'm going to call that one 79.15. Now, here in both examples, I've underlined the last digit, the estimated digit. Okay, again, we might have different numbers there. You might 79.16. You might say 79.14. The important part is that you have that digit. We have that estimated digit because that's really telling the reader how accurate is your measurement. Right? We know it's 79.1. We know it's at least 79.1 in the second case, about how far in between them, and that tells us that last digit gives you a better idea about what the measurement is. Very, very important. All right, so here's a practice problem for you. We've got 35 on our label tick mark up to 40. How many tick marks are between them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome. 10 tick marks. We went 5 milliliters and 10 tick marks. All right, 5 divided by 10 is 0.5. So each tick mark is 0.5. So let's label them on the side here. So each tick mark, I'm going to go up by 0.5. Right. So now how are we going to read our volume? Well, we know we're at 35. We're nowhere above 35.5. Right. So we're in between the 35.5 and the 36 tick mark. About how far in between? We're just kind of eyeballing that bottom of our meniscus here. That's less than halfway between the 35.5 and the 36.0. So I'm going to say 35.54. I'm going to my estimate for the last digit is 4. If you said 3, you said 2, you said 5, awesome. It doesn't matter. 35.5 something. I need to see that estimated digit. Very, very important. And again, that'll be something you'll see on a quiz and or a test. Okay. So let's do a little practice on reading the increments of our graduated cylinder. I'm going to go through this very quick. If you look at it, what I want you to do is look at the labeled tick marks, the 0 and the 1. How many tick marks in between them? 1, 2, 3, 4, 5. So we have 5 tick marks between them. How far did we go up? 1 milliliter, and it took us 5 tick marks. 1 divided by 5, what's that tell you? 0.2. And again, don't forget to put your units on, milliliters. Graduated cylinder B, right? 0 to 10, we have 1, 2, 3, 4, 5 steps to get there. So we're going to take 10 milliliters divided by 5 tick marks. That tells you 2 milliliters per tick mark. And we can look at the other ones too. Again, I want you to count the number of tick marks in between the two labeled ones. Take how far did you go? 10 milliliters divided by 10 tick marks, 1 milliliter per tick mark. Right, and finally, D, we went from 0 to 1. It took us 2 steps to get there. 1 milliliter divided by 2, 0.5 milliliters per tick mark. Okay. So let's do some practice here. I've got some meniscus drawn on these. Now we know how to calculate our increments for each tick mark. So we're going to go through here. And again, I'm going to go fast for the speed of time. Hopefully, if you need to count these tick marks, please go ahead and do that. We know that we got 10 tick marks in between our 20 and 30. Each tick mark then is 1 milliliter, 21, 22, 23, 24, 25. So we're above 25, little bit above 25, so maybe 25.1, 25.2. Either one of those numbers will work. 25.1 is what I chose here, and we're going to say milliliters. Again, don't forget to put your units on there. 35 to 40, 5 tick marks. 5 milliliters over 5 tick marks gives you 1 milliliter per tick mark. We're at 35, 36. We're between 36 and 37, so we all should have 36 to start with. How far are you between 36 and 37? I'm going to say a little bit more than halfway. So maybe I'm going to say 36.6, 36.7, 36.5. Yeah, any of those would be good, something on there, as long as you get somewhere close. Don't tell me 36.1. I can tell that it's much farther. It's at least halfway between those two. All right, graduated cylinder C, 5 to 6, we have 10 tick marks. Each tick mark then is 1 milliliter divided by 10 tick marks. 0.1 milliliters per tick mark gives our calculation. So we're at 5.1, 5.2, 5.3, 5.4. Again, we all should start with 5.4. Estimate that last digit between 5.4 and 5.5. This looks right about halfway between, maybe a tad above. So let's call this maybe 5.56. I'm sorry, 5.5. I did it wrong there. 5.1, 5.2, 5.3, 5.4. We're in between 5.4 and 5.5. Most of the way between the two, 5.48. Again, if you have a different number here, if you don't have an 8 at the end, as long as it's close, 6, 7, 8, 9, those are all good. And finally, our last one, how far we go, 10 milliliters over 10 tick marks. That means 1 milliliter per tick mark. 10, 11, 12, 13, 14, not quite 15. So we all should start with that 14. We're really close to the 15 line, so we'll say 14.9 tick marks, or 14.9 milliliters, sorry. On this one, I would like you to practice drawing your meniscus. How do we do that? Again, we're going to do the same thing, 49 to 50, 1 milliliter, 10 tick marks, 0.1 milliliters per tick mark. So we're looking for 49.21, 49, 49.1, 49.2. Our meniscus is going to be just a little bit above that 49.2 line. Just a little bit above that 49.2 line. So I draw my meniscus like this. Again, it's the bottom of the meniscus we're looking at. 18.2 for our next one. We have 5 milliliters. We have 5 tick marks. So each tick mark is 1 milliliter. We're at 18. So 15, 16, 17, 18. So we're just a little bit above that 18 tick mark. Let's draw our meniscus there. Again, look at the bottom of the meniscus to do your measurement. 27.65. We got 27 to 28, 1 milliliter. It took us 1, 2, 3, 4, 5 steps to get there. So each tick mark is 0.2 milliliters. We're looking at 27.65. So this is 27.2, 27.4, 27.6. So we have to go a 0.05. So we're going about a quarter of the way between our 27.6 and our 27.8. Draw our meniscus. And again, the bottom of the meniscus is what we're looking for here. And finally, the last one here, 63.8. 10 milliliters, 10 tick marks, 1 milliliter per tick mark, 61, 62, 63, but we've gone 0.8, so we're closer to the 64. So we want to draw our line just under that 64 milliliter mark, and there you go. Right, so the bottom of that meniscus is a little bit below our 64 milliliter mark. All right, that'll wrap us up for reading a graduated cylinder. So now I want to talk a little bit more about how we're going to actually measure the volumes and masses of objects in chemistry class. On to the next part of our notes. In this part, we're going to talk about ways to measure mass and volume. We learned a little bit about measuring volume with our graduated cylinder a moment ago. Now we're going to take it a step further. So I'm going to talk about mass first. So how are we going to measure mass? We're going to use tools like this. This is our scale that we're going to use in the back. And this guy is, the units we use for mass are grams. This particular tool can measure to 0.01 grams. And you'll see that in the display down here. It'll say like 3.42. You can read to that hundredth of a gram. Very precise scale, very expensive instrument. All right, this is an electronic balance. That makes it easier. We don't have to estimate that last digit, right? On the graduated cylinder, we had to estimate it. Here, the balance is telling us what that unit should be. Always, when you're using an electronic balance, use the same balance for the whole experiment. Right? I have a couple of them back in the prep room. Make sure you use the same one. Why are we going to do that? It minimizes error. Not all the balances are calibrated exactly the same. And when we're talking about 0.01 grams, that gets important. Right? So now use that same balance for the whole experiment. Now, that doesn't mean you have to use that same balance for the whole year. Next experiment, you can use a different balance. It doesn't matter. Just for a given experiment, make sure you use the same balance the whole time. Tare. Sometimes you'll hear me talk about a tare, right? What we'll do that, that's a way that we put a little container on here, and then we'll zero out our balance, right? And that's what we're talking about, a tare. It's something we're going to put on there so we can put chemicals on there. So the way we tare it, right, is you'll see there's a button here that says on, 0, or off. On, 0, or off. What we'll do is you'll press that. It'll usually be on. Just press that button once more and let it go, and it'll change the reading to 0 here. If you've got something like a container sitting on top of here, it changes it to 0. And the nice thing about that is then when you add the chemical in, it tells you how much mass comes right from the chemical. We've already taken out the mass of our container. We've already used the tare to zero that out. All right, so rules. When we're using one of these guys, please do not push down on the top of this. These are very sensitive. You can damage it by doing that. And again, they're very expensive. If one gets damaged, we don't have enough budget to get another one. We'll be down a balance for the rest of the year. So please treat these things carefully. Do not press down on them. The second thing, chemicals do not go directly on this pan, this top part here. That's why I was talking about a tare before. Usually we'll put a beaker on here, or we'll put a little plastic plastic bowl that we'll call a dish or a weighing boat. We'll put that on here, but nothing goes directly onto this pan of our scale, of our balance. Right? No hot objects either. Right? We don't want to put hot objects on here. We're going to put the hot object in something else. We want to protect the top of our balance. And always leave the balance on, please. Don't turn it off. Right? It'll be on. Put your container on here. Press the 0 button to get it zeroed. Put your chemical in. Weigh your chemical. Take your beaker or your weighing boat off. Leave it alone. Leave the scale on, please. And finally, the last one, don't use anything but a finger to push the buttons. Don't use pens. Don't use sucker sticks. Don't use God knows what keys. Use your fingers, right? That's what these were made for. Let's not damage them by using something else. All right. Now that we know how to use our scale, our balance, how are we going to measure mass with it? One other way besides just putting a beaker on here or a weighing boat and then zeroing it, we can weigh things by mass. We can determine the mass by weighing the differences. So what do I mean by that? That means, here, let's use an example of a beaker that has some salt in it. If we weigh the beaker by itself, right? We just do this mass of this beaker here by itself. Whoop. Put the empty beaker on here. We weigh that beaker. Great. We know how much the beaker is. Now we do our reaction. We have some salt left over in the beaker. Let's weigh the beaker plus the salt. Weigh the beaker plus the salt. So we get 2 measurements. That gives us our total mass. Well, if we want to understand the mass of the salt, what is it? The mass of the container we measured first. We measured the total mass at the end. Well, what's the total mass at the end? That's the mass of the container plus the salt. So if I say total mass, instead of saying that, I say mass of container plus salt, and then subtract mass of container, what are you left with? Just the mass of the salt. So sometimes we'll do mass by difference. These scales are nice. They have the 0 button. We won't need to do this very often, but there will be times we're going to need to use this kind of calculation. Right? Just remember, we want to know what the container is before the reaction. We want the container weighs after the reaction. The difference between those tells us the amount of stuff that we put into our container. Let's talk a little bit more about measuring volume. Right? We measure the volume of liquids. That's really easy. We use our graduated cylinder. Remember, our units are 1 milliliter on here. Right? And you read the bottom of that meniscus, that curve. Read the bottom of that curve. Make sure you get to eye level. Don't pick up your graduated cylinder. Read it. Put the graduated cylinder on your desktop. You bend down so your eyes level with that bottom of the meniscus, and then make your reading. Our larger graduated cylinder, each tick mark is 0.1 is 1 milliliter. So when we estimate that last digit, that means we're estimating to 0.1, the 0.1 milliliter place. Our smaller one, it has 10 tick marks between each milliliter. So each tick mark is 0.1 milliliters. We estimate that next digit, that's 0.01 milliliters. Now, just like I was talking about your scale, and we can measure balance, we can measure mass by difference, there are different ways to measure the volume of a solid. Now, sometimes it's real easy. It's nice. We can use simple math to do it, right? If we're going to look at the volume of this is our density calculation. We'll go over that a little bit later. If you want to measure the volume of a block, what do? Length. You measure the length, you measure the width, you measure the height, multiply them together. Right? 4 centimeters times 3 centimeters times 10 centimeters. That's going to give you 120 cubic centimeters. Just multiply the 3 measurements together. Blocks are easy. Volume of a cylinder, pi r squared h. Pi, hopefully your calculator has pi on it. R, what's r? That's our radius. So we can measure the radius of our cylinder. H being the height of our cylinder. And if we have something like a sphere that's like a marble, right? 4/3 pi r cubed. R here again being the radius of our sphere. So if our solid has a nice shape, a well-defined shape, we can just calculate it mathematically. We don't need to use a tool. We don't need to use a graduated cylinder or anything to measure it. We can just take a ruler, measure the sides, and we're done. But what if it's not something that's that simple? What if it's a very irregularly shaped object? Let's see, what can I think of? Like a key, for example, a car key, for example, or a pen, or let's say a cork. Something along those lines, something that's not a well-defined shape. Then we can't use math to figure it out. So we're going to do volume by displacement. What do I mean by that? We're going to use our graduated cylinder. We're going to put some liquid in here, and we're going to read how much liquid we started with. Right? Then we're going to put our object in it, and we're going to read the volume again. Right? So our initial reading, before we put some liquid in, that's our starting volume. We're going to put our object in. We're going to read our final volume, right? So it's going to go up a little bit, right, depending on the volume of our object. We subtract those two numbers. Right? That'll give you the volume of our irregularly shaped object. And we'll do a lab on that. Right? One last thing I want you to know, and this is a number I want you to memorize, one of the few. There's only like 5 or 6, I think, all year. But 1 milliliter is the same thing as 1 cubic centimeter. That's a definition inside of our metric system. Please don't forget that. All right, guys, so that's the end of our notes today for measuring things. Don't forget to take today's quiz, the 3-question lecture notes quiz, and we will see you tomorrow. Take care. Bye.